This is Unit 15 for Conceptual Chemistry, the study guide, questions 2, 3, and 4. So with question 2, the question is asking for you to explain the process of dissolving through pictures. So for that, you have to understand that your solute is going to be made up of a substance that is probably going to be in a crystal form or solid form. Basically, your solute is going to be kind of clumped up. And then your solvent is going to be kind of coming in from all directions, trying to dissolve or break up your solute. So in this case, your solvent is going to be out here. And as the two interact, what you're going to have is you're going to have the solvent coming in, interacting with the solute, and then carrying it away. So that slowly but surely, you'll get a solvent, say like this, and then some of your solute will have broken up. Maybe some of it's still going to be clumped up together right here, but some of the solute will start to be spread out throughout the solvent as a solution, so that when you're finally finished, you will have something like this, where the solute is evenly broken up amongst all the pieces of solvent, so that you have this nice homogeneous mixture or solution. So that essentially our first picture is leading to our second picture, which is leading to our third picture. We're getting the gradual kind of breaking up of the solute until it's evenly distributed. Now, as we go into question 3, that's where we start talking about the rules for ionic and covalent dissolving. So what's the difference between these? Well, in covalent, right, whatever your covalent compound is, so for example, carbon dioxide, it doesn't break up. It doesn't split. So all that's going to happen are individual molecules of carbon dioxide are going to be separated out throughout the solvent. So that in this case, our CO2 is just one of these red dots, one of these red solutes. So the whole molecule is traveling together. We're not breaking those covalent bonds. Each one of those red solute dots or circles represents one molecule of CO2. Now, when we compare this to ionic compounds, the difference is that with ionic compounds, they split into ions. And the ions are going to have a positive charge and a negative charge. So for example, if you have something like magnesium oxide, when it gets dissolved, it's going to split into the ions, the cation of magnesium with a positive 2 charge, and the anion of oxygen with a negative 2 charge. So that when we look at this, we would say that our magnesium and our oxygen are different red dots, okay, different solutes. So that we get twice as many solute particles because the ion actually splits, or the ionic compound splits into ions. Okay? Now, question 4 is saying, okay, we want CO2 to dissolve, or we want magnesium oxide, our ionic compound, to dissolve. What can we do to increase the rate of dissolving? Well, there's 3 things, but they all hinge on one idea, and that is we need to get interaction between our solute and our solvent. So if we look at what's going on over here, for question 4, you're trying to get the solute to interact with the solvent more often. In other words, you want them to collide or come in contact with each other more often. So the things you can do is you can agitate, meaning stir, agitate or stir. You can heat it, which is going to cause things to move around faster with more kinetic energy, so we're going to get more collisions. Or you can increase the surface area of the solute. So surface area of the solute. In other words, we can grind it up into a powder so that there's more small pieces of solute floating around that will have the opportunity of colliding with our solvent. So that's questions 2, 3, and 4.